Hello, boys and girls. We're continuing with topic 16. We have been looking at angles and vertices, verses, and polygons, and how to measure all those angles and how to classify those polygons based on the number of sides and angles and vertices that they have. We are going to focus in on a specific type of polygons today, which is called the triangle. And if you remember from yesterday, the triangles are classified because they have three sides. If I draw that triangle right there, and then three vertices or angles where those sides meet. We are able to use the lengths of these sides and the measures of these angles to help us classify triangles. We're first going to look at how to classify these triangles based on their sides. So if we look, we can classify these triangles by their all three sides being the same. And our first triangle, if you look here, is an equilateral triangle. That means that this side here, and this side here are all exactly the same length. All sides are equal. Our second type of triangle is our isosceles triangle, where two sides are equal. So this side and this side are the same. That bottom side, if you look, is much shorter than the other two sides. And that is what we would call an isosceles triangle. We then have our scalene triangle, which is down here at the end. And that means no sides are equal. All three sides are a different length if you were to measure them with a ruler. And this one's pretty obvious. This one's very long, this one's a little bit shorter, and then this one's much shorter. So that is the three ways or the three names that we could classify our triangles by their sides. And you may have known that before, that you could say, oh, well, all these sides are equal, or these two sides are equal, that one's different, or this one has no equal sides. But now you know the actual terms that go with it. So we have the equilateral triangle, the isosceles triangle, and the scalene triangle. Okay. So if I was to draw a triangle right now, let's see if you can name it. Let's see if you can name that triangle right there that I just put on the screen. And if you looked closely at this triangle, okay, I purposely made it so it was a little bit tricky to look at, but if you looked, this is our shortest side, okay? This side is a little bit longer, and then this side is much longer. So all three sides were different, therefore, it was a scalene triangle. All right, let's take a look at another part of this triangle real quick before we flip to the next slide. So we've been naming these three triangles based on the lengths of their sides. We can also look at the angles. And hopefully by me drawing that little square and that triangle right there triggers some memory from the last few lessons, and that means that it's a right angle. So we can also look at our triangles and look at the angles within side to classify those triangles as well. So for example, before we even go to the next slide, this would be a right triangle because one of its angles is a right angle. So going to our next slide now, if we look, here is our right triangle that we just had on the other screen. Okay, and there's that right angle. It doesn't mean that all three angles are right angles, just at least one of them. Okay, and that's the one you'll be able to notice the easiest because I think it has that most obvious angle to it. Then we have our acute triangle, and if you remember, acute angles are all less than 90 degrees. That means they need to be smaller than 90 degrees. And that means all three angles are less than 90 degrees. Okay, so all of its angles are less than that 90 degrees. Then we have our obtuse triangle. And obtuse, if you remember, is everything is greater than 90. Those angles are greater than 90 degrees. In an obtuse triangle, however, unlike the acute triangle where all three have to be less than 90, an obtuse angle only one needs to be an obtuse angle in a triangle. It would be a pretty difficult triangle to draw if all three were obtuse angles. So it's the only difference between our acute triangle and our obtuse triangle. In acute, all three have to be less than 90 in order to classify like that. An obtuse triangle only needs to have one of its um, angles to be above 90. I want to look at this middle one. So on the previous slide, we learned how to classify triangles named based on their sides. And on this slide, we looked at how to classify them by their angles. We can classify them using both. We know that this one's an acute triangle already based on its three angles. But if you look at your three sides, all three sides are also equal. So this would make this an equilateral triangle as well. So you can use both names to classify that triangle. So I want you to take a look over at this obtuse triangle, okay? We know it's obtuse. It has this angle right here that's greater than 90. But if you look at the sides, how else could you classify this triangle? And if you guessed scalene, you are correct. None of its sides are equal. So not only is this an obtuse triangle, we can name it also based on its sides as a scalene triangle. So when you are working on your practice problems tonight, keep in mind that you can name a triangle more than one way based on its angles and its sides. All right, boys and girls, thank you.